for whatever questions you want to throw at me.
I did have one question from, I believe it was section 7.1, integration by parts. And it's, I remember I had the homework assignment. I believe it was problem number 7, and it was just kicking my butt.
Have you got it handy?
Yeah, I do.
I can look it up.
I'm pulling it up now. Here we go. And the way I solved it just was kind of weird, but I couldn't get the right answer. But it goes, it's evaluate the integral, and it's the integral of 9 arctan 1 over x dx.
Did you say 9?
Yes, 9 arctan, and then it's 1 over x in parentheses, and then dx. And the limits of integration are square root of 3 and 1.
You're right. That is one ugly looking integration by parts.
It's backwards. It's square root of 3 is the upper limit.
Up here? Okay. Well, it should be because it's bigger than 1. I should have realized that. Okay. A is integration by parts. It's in a section that says integration by parts. If I did it in a final, I would say use integration by parts and then give you the question. So when I tell you a technique, it is an instruction, not a suggestion. So do it that way. One is I want to find out, do you know how to do integration by parts? And the second is that's probably the only way to do it. So it saves you trying to do weirder stuff that doesn't work. Now, I have to pick an F and I have to pick a G, and this is not a standard one. And it's there are 2 choices. I can make the 9 an F, or I could make the inverse tan an F. And if I choose one, it doesn't work. And if I choose the other, eventually it does work. So this is going to be the F and this is going to be the G. And so that's F, big G, take away the integral of F dashed, big G, d of x. So before I continue, let me tell you why I chose that. One of the ways of deciding who F and G is ask yourself, can I integrate it? And if the answer is no, I cannot integrate it, make that F. Can I integrate 9? Yes. Can I integrate the inverse tan of 1 over x? Hopefully you would say not in a million years. And the answer is correct. Right now we can. So that's how he is F, right? The one you cannot integrate, make that the F. That's kind of how you make the decision when you're looking at some weird situations. It's a little bit easier when you looked at the earlier ones, but not for this one. Now, these are the bits, but I'm going to do some of this at the side because some of the things are not that easy to do. So F is going to be the inverse tan of 1 over x. And I need to know the derivative of this guy. Okay, if you look up your list, you know, your standard derivative, standard integral table, isn't the derivative of an inverse tan 1 over 1 plus something squared? So this is going to be a chain rule. So it's 1 plus 1 over x squared, followed by the derivative of 1 over x. Can you trust me that the derivative of 1 over x is eventually that? Okay, so the derivative of inverse tan of 1 over x is 1 over 1 plus 1 over x squared times the derivative of 1 over x, which is this. And now we are going to do some style points. And if you multiply the top together, you get -1. And this guy times this is x squared, and this guy times this is 1. Right. Was there a question there? Are we good? Right, so, I mean, it did look horrible, but I guess it's not that bad once you tidy it up, once you do the style points. Now, we still have G to do, but I'm only doing this for completeness sake. Dead easy to integrate G, right? It's just 9x. So I'll return now back to our question. So it's going to be f, which is this fella, times g, which is capital G, which is this fella, take away the integral of f dashed, which is this fella, times big G, which is this fella. And this is going to be 9x, the inverse tan of 1 over x. Two negatives make it a plus, and multiply the top together, and there's your bottom. And now we're there. Okay. I need to integrate this guy, which I'm going to have to do at the side as well, because it's not an obvious, well, it's not an easy integral to do in your head. What technique am I going to use to integrate this ugly fraction?
U sub?
Yeah. So do you see that this question not only had an integration by parts in it, and a chain rule differentiation in it, and some horrible algebra in it, it's now got a U sub in it, and we aren't even finished yet. So can you see this question is kind of picking up tools from all sorts of places and putting them all together. Now, the U sub here, oops, there's an X there. The U sub here is x squared plus 1. If you differentiate it with respect to x, you get 2x. If you do the crossover, oh, darn it in space. You do the crossover, you get that. And if you isolate the dx, you get that. So this becomes 9x over u times 1 over 2x du. Cancel out the x's, and you get 9 halves 1 over u. That gets you 9 halves, not natural log of u. That gets you 9 halves, the natural log of x squared plus 1. And we now have a little bit more information than we had a while ago. We still have this guy plus the integral of this. And if this didn't have limits of integration, I'd be putting a big plus c here, but it does. So it's now going to be from x equals 1 to x equals root 3. And let's see what that gets us. 9 times root 3, the inverse tan of 1 over root 3, plus 9 over 2, the natural log. If you do root 3 and you square it, you basically get 3, so it's 3 plus 1. Take away. 9 times 1 is 9. The inverse tan of 1 over 1, which is 1, plus 9 over 2, the natural log of 1 plus 1, which is 2. Right, we're going to have to find out who the inverse tan of that guy is. It's going to be 4. Take away 9. Oops, inverse tan of 1. Shouldn't have written that down, but too late now. 9 over 2, that guy. Okay, if you want to get the inverse tan of 1 over root 3, this is a kind of a cheat, but it works. Make sure your calculator's on degrees. Do the inverse tan of 1 divided by the square root of 3. And you see the answer is 30 degrees. And then remember that we're always in radians, so 30 degrees becomes pi over 6. Do you like the cheat? Okay. Now, the inverse tan of 1, if you did the same thing, you'd get pi over 4. That guy, well, there's not a lot happening. 3 cancels. 3 root 3 pi over 2. You might be able to do a little bit more style points in this, but there's not an awful lot you can do to it. It's pretty ugly, but that would be the answer. And I just noticed something. You're subtracting both of these, so both of them are negative. If you got this question, it would definitely be a section 2 question. Right? It's just too big to even be thought of as a multiple choice. Are we good? Okay, where am I going next? Any questions?
I feel like there's only like 9 of us in this class. Do you guys ever get the same feeling?
I get the feeling I'm on my own half the time.
Well, I would be with you like saying stuff, but I mean it's kind of like you don't want to be like the only 2 people like saying stuff in class.
I hear you. Some people are very shy. And what's that phrase I heard? They don't do stupid. So they're always frightened to asking a question. And people think that they're somehow not bright, which is kind of strange. Because you're doing calculus 2. It's not like you're doing arithmetic. And you're saying, what's 5 times 2? I mean, you're not asking stupid questions. I mean, you might get a stupid answer, but that's my problem. So some of you are just shy.
Hector, on submarines, do you ever hear the saying, if you're going to be wrong, be loud and wrong?
No, but I've heard if you're going to be wrong, if you're wrong, stay wrong. But speaking of dumb mistakes, I realized what I did wrong with that prob we just did. And it was a pretty dumb mistake. I had, at the very end, I had 9 times the square root of 3 times pi over 6. I simplified that to 2/3 pi times square root of 3 times 3/2. It's like one of those, like, yeah, I messed up at the end, but I would get most of the points right for that.
Exactly, right. So,
Just,
yeah, when you're doing these questions, try and remember that partial credit will save you a lot of stress. I mean, if you're doing the process right and you didn't cancel a fraction exactly, or like I did, I forgot a sign, right? I just didn't translate it right. It's not good to be wrong, but they are easily fixed mistakes. They're not process mistakes. Process mistakes will kill you, right? I mean, if you try to do that question, but you switch places with the F and G and somehow try to, fiddle it, it wasn't going to work. That would not be a good move.
yeah, but like this one just blows my mind because I went through it like a few times. It was like, where the hell's the mistake? Part of my French, but it was just that simple simplifying, canceling the bread and butter steps.
Yeah, when you're doing the final and you're finished and you've got some time and you want to go through it, it's always good to go through it just in case there's a little 2 or a plus or a minus or something you can see quite quickly. You'll find very often that if you make a mistake and it's not an obvious thing to see, that you will look through your working and it will look okay, but you kind of know the answer's not right. Like it's a volume and a volume should be positive, but how come your answer's -4, right? So you kind of know it's wrong, but you can't figure out why it's wrong. And the best advice I can give you is don't do anything. Leave the first question alone. Because if you know you're doing the process right, if you try and do the question again, isn't that going to take you another 10 or 15 minutes that you could be doing other things and maybe picking up better points? And the chances are that whatever mistake you made the first time, you're either going to do the exact same mistake because it seemed like a good idea the first time you did it, so it's probably going to seem like a good idea the second time. Or you fix that one, but then you make a totally different little mistake and you still don't get it to work. So I would do that. That would be my advice. Oh, what's my advice? I'm sure I've mentioned it, but it tells me if you're paying attention. What's my advice if it's taking you more than 5 minutes to do a multiple choice?
Skip it.
And call it what?
Call it a day.
No, call it C or A or B. Don't just leave it blank. I mean, at least call it a letter of the alphabet. You got a 1 in 4,
When in
1 in
doubt,
5
Charlie
chance.
out.
Right? That one, the military one. Any other questions? Maybe I should pick someone. Who have we got? Victoria. I was going to pick someone, but you just saved someone from being chosen. So what's your question?
I have a specific homework question from
Sure.
9.5. It was number 9. And
You got a
mine,
handy?
yeah, I do. At least my version, it was 9 plus t du dt plus u equals 9 plus t. But it also had like the t is greater than 0 as well.
Right, that's just why you're asked. That's just to make the
Okay.
question sense. Because sometimes the answer's a log.
Yeah,
And
that's
the-
why.
And that's why they put it there. But
Yeah.
if you ever see a t greater than equal to something, it's just to be mathematically correct. It's not really a big deal. So you want to solve this one. Did this have a boundary condition? Or is it just a, so it's going to be a plus C one then, right? Okay, it definitely, first, have I written it down correctly?
At least on mine, it's
Right.
no, not
Let's
not.
see. Okay, now, if you were doing a little who is who, isn't U like the Y and T is like the X, right? So I don't want that 9. Actually, don't those 9s cancel out? Which is kind of interesting. So if I just do that one at a time, try not to do too much. Oops. Isn't there a problem that du by dt needs to be in its own, and right now it's not? And so if I divide everybody by t, I get that. Do you know I've written the u over t, I've written it as 1 over tu. I think it's more helpful to write it like that. That means I can identify the p of t and the q. Actually, the q is just the number 1. Getting interesting. I can then do the integrating factor. This one's actually not got too much weird stuff going on, because doesn't that just simplify down to t? And so my solution used to be called y, but it's now going to be called u. And it's going to be 1 over it, the integral of it qt dt plus a c. So 1 over t, the integral of t times 1, which is just t. Well, this is scarily easy. That always worries me. Probably worried you as well. Great. I would probably distribute the 1 over t here. And that would be my general solution. Was it the t greater than 0 that was freaking you out or distracting you?
I think it was the beginning algebra kind of messed me up a little bit, just kind of tweaking things around.
Yeah, because when it's x's and y's, you're comfortable because x's and y's kind of have a place and you're used to them. But the minute you start calling it R and S and U and T and V and W, it's a little bit harder. A suggestion, I'm not saying you need to do this, but suppose we had this question again and you just wanted to visualize what was going on. That guy there is important because what that guy there is, he tells me that U is like the Y. Right? And then the other guy, that's like the X. And then, if it really helps, not saying it does, if you look at it like that, does it look a little bit more natural to your eye? And therefore, the algebraic manipulations could probably be done. You could actually keep going and get your answer. And when you got to the answer, it would look like this. And then couldn't you just turn it into that? I'm not saying you need to do that, but if it helps you visually, that's totally acceptable in mathematics. Haven't you basically just turned the question into the same question, but with different variable names? You've not really altered it in any significant way.
Thank you.
Yeah, welcome. Right, I was going to pick on someone. So does anybody want to volunteer to save some other poor soul being chosen? Okay, Anya. Oh, go for it.
I was going to say, I don't have a specific example, but do you think we could do a partial fractions?
Yes. I've just figured out how to get this class to ask questions. Threaten to ask someone else, and you're all jumping on the grenade to save someone. I'm still going to ask someone, so, but not right now. Okay, suppose that you had to do that guy. Okay. So far, so good. Now, this is going to be a partial fraction question, but I made it a little bit trickier by not writing it down the way it needs to be written down so that it's more obvious that it's partial fraction. Have you noticed that the bottom can be factored? And there we go. And it can be factored like that. Because in a lot of questions, isn't the bottom already factored for you, so you don't worry about it. Now, in this particular case, we got lucky, because can't we do the cover-up method? Otherwise, we'd have to do the general algebraic method. So I know it's going to split as an a over u minus 2 plus a b over u minus 1 du. And I know that because as long as the top is smaller than the bottom, this will work. If the top was like 2u squared, I'd have to do some long division and then I would do what I've got here. Okay, let's figure out who the two pieces are. Okay, I want the A, right? I want the guy that goes up here. Now to get the A, I cover up with my finger the u minus 2. I then choose 2, right? The number that makes that 0. And I plug it into what's left. So what do I get? 2 lots of 2 plus 1 is 5 on the top. 2 take away 1 is 1 on the bottom. 5 over 1, I got 5. Okay, let's get B now, the one that goes here. Cover up the u minus 1. There we go. The value of u that I replace here is whatever makes u minus 1 0, which is 1. So 2 times 1 plus 1, that's 3. 1 take away 2 is negative 1. 3 over negative 1, we've got negative 3. And that is called the cover-up method. Do you recognize that both of these are natural logs? And that's what you'd get. If you had numbers in like from 2 to 5, then instead of the plus c, you would do u equals 2 to u equals 5. So that would become 5 take away 2 is 3. 5 take away 1 is 4. Ooh, okay, I'm going to have to make that 3. So that's going to have to turn into 2. Right. That gives me 5 natural log of 1s, take away 3 natural log 2s. That's 4. There we go. And then make it look pretty. Do you want to see a general algebraic method of that question? Okay, that would be quite different in one very big respect. Let's assume that they were nice to us and they made the bottom factor, so I didn't need to do that. If you want to do this fella, it splits. It splits as AU plus B over U squared plus 1 plus a C over U minus 2. Are we all comfortable about how to split them into their partial fractions? The U squared gets 2 terms, the linear just gets a C. But then things get quite complicated and messy for a while. I need to take these two guys and I need to join them back together again. So there's the first one. And I'm going to multiply it by a special version of 1. And here's the second guy. And I'm going to multiply it by a special version of 1. And I want to add these two fractions together, so they need to share a common denominator. So this one, I choose that version of 1. And for the second fraction, I choose that version of 1. So I now have this guy times that plus this guy all over these two is the same thing as this guy all over these two. So essentially what our goal is, we need to find out what numbers A, B, and C are. And this is what this is part of, what we need to do to get there. We then make a very simple assumption, and that is that if you have two fractions that are equal to each other and they have the same bottom, the same denominator, then it's kind of logical that the top should be equal as well. So that's what that line is saying. Are we good? Right, now, we then enter this choose values of U. And we don't just pick 42 or 77 or whatever comes out in our head. We choose a value of U that allows us to get one of the three missing letters, A, B, or C. And it's very often you have to do it in a very specific order. And you choose the U so that, in this case, 2 of the letters disappear and there's only 1 letter left. What's going to be the magic value of U that helps us with this the first time around?
2.
Agreed. Now, 2 lots of 2 plus 1 gets me 5. I don't need to write what that is because isn't that just going to be something times 0? So it's just 0. And then 2 goes here. That's C equals 2 squared plus 1 is 5. So I'm really surprised at myself because normally don't you get things like 3/17 when you do these? There's not very pretty answers. But this answer is really pretty, it's 1. Then you have to remember to rewrite this line, but change the C into 1. See, I know C is 1, so C is 1 times this. 1 times this is just that. And then you just repeat the process. What should be the next choice for you?
Zero.
Yeah. Can you see why 0 is a good choice? Doesn't it kill the A? So what do I get? I get 2 lots of nothing plus 1, which is just 1. A times nothing means it's going away, so you've got B. And nothing take away 2 is -2. And nothing squared is nothing plus 1. If you sub, ooh, this is a weird answer. I kind of like this question. B is 0. I don't think I've ever seen one where one of the coefficients was 0. That's kind of cool. That was just sheer luck. And oh, by the way, it's okay to be 0, right? Just means it's not there, right? It's okay. Does mean my next line is going to look kind of weird. I'm going to take this line here and replace B with 0. So we now have 2u plus 1 is equal to AU plus nothing. So it's just AU. U minus 2, U squared plus 1. And if you do it right, won't you be left with just one variable as we are now? And we still have to choose a U. What U value would be a good choice this time? And don't pick 0 or 2. 1. Yeah, why not? 2 lots of thingy, that gets you 3. A times 1 times -1 plus 1 squared plus 1. Oh, I could not have made that up if I tried. But look how nice A is. Wow. So we now know A, we now know B, and we've got C. So we should be able to return to the original question, which is this fella. And replace it with AU plus B over U squared plus 1 plus C over U minus 2 du. Tidy this up a little bit. So our original fraction has now been turned into 2 partial fractions. And we're not finished, but we're done close to it. Would you agree that this guy here is easy to integrate? It's just a natural log. What do you think I'm going to have to do with this fella? The integral of -u over u squared plus 1.
Normally be a U sub, but you need to choose a different letter.
Yeah, well, that's true. I can't use a U sub when the thing's called U. So I'd probably call it a W sub then. Can you trust me on this one that it ends up being -1/2 the natural log of u squared plus 1? Can you just say, I did it and I got that? You can check it, it's all there. And there's your answer. So it's time for me to pick my victim. Anya, you're getting picked.
All right. Can we
Right.
go over like volumes of rotation?
God, I didn't even get a chance to do the question. You had one waiting for me. Yes, we can do volumes of rotation. There are tons of different flavors of that. Is there any particular one you want me to do? And do you want to do a single curve X, single curve Y, area between curve X, area between curve Y, disk or shell method? That's why there's tons of permutations. Any particular one?
Not really.
Okay. How about then the volume between y equals the square root of x, which is this guy, and
Sorry.
y equals x cubed, which is this guy, pretty common shape, and we'll rotate it about the x-axis. So we want to know the volume of this shape, starting at 0.
We just so you know, we can't see.
See anything? I can see it. Right. So I've just picked one of the, the banana shaped questions, just so you can talk about the method, right? So you've got a x cubed, you've got a square root of x. This point here is 1. You can check it yourself, but you are allowed Desmos. That will be put on there'll be one module it's called, and in that module, there will be the graphing software as well, right? So all the GeoBra and all that stuff. So you are allowed to use that during the final. So I would certainly use it to do a sketch of this if you weren't sure what it looked like. Now, when you do the volume, I'm going to do the pi, the integral from a to b of fx squared take away gx squared dx. You remember that formula for rotating the difference, the area between two about the x-axis. So there's pi, it's going to be 0 to 1. There is a decision to be made here. If I do a little baby vertical rectangle, which one goes first? The square root or x cubed?
Square root.
And the reason for that is, isn't it higher up than the other one? So square root of x gets squared and the x cubed gets squared. Now, can you imagine they weren't really nice functions, but really ugly functions? Wouldn't they still be the same basic shape, right? Big guy squared, take away little guy squared. So you'd have to do some foiling or, whatever it was, but eventually you would get it. In this case, I've kept it relatively quick. You get that? Power rule. Power rule. You get a half, take away a 7, minus a whole load of zeros. That's 7 14s, take away 2 14s, you get 5 14s. Now, because I chose very simple functions, what this does is it allows you to maybe see the process without getting too cluttered up with weird curves. But I've seen questions where these are things like the sine of 2x and this is like the cosine of 3x, right? So you're going to have trig identities. You're going to have to integrate sine squared 2x or something. And, x squared plus 1 has to be squared, in which case you FOIL it out and you get a much uglier thing. But all that is the details. It's still big guy, take away little guy. Suppose you did this question and that's the answer you got. Could happen if you did something wrong. What do you think you did wrong to get that answer?
You got the f of x and g of x backwards.
Right. Now, in an exam, imagine this wasn't a nice quick thing, right? This one here, I think I could have gave you this question as long as it was these functions as a multiple choice, because it would take you about 5 minutes, right? Wouldn't take you longer. But can you imagine these are really ugly things and you had to do, I don't know, U subs and all sorts of things to get the answer. And it wasn't until you got here that you said, oh, flipping bananas, I switched them. This is how you fix it. You say, oops. Switch the F and the G. Correct answer equals 5/14 pi. And I will know that you knew what you did wrong, but you're just not going to rewrite the entire bloody question, because it could take you 15 minutes to rewrite it again, right? And you already have told me you know what you were going to write, right? You know, I was just going to switch everything and I'm going to get the same answer. And I even know that it's going to be positive 5/14. Won't that sometimes happen when you do the area between two curves? Couldn't it happen with an arc length, and couldn't it happen with a surface area? Because shouldn't arc length, surface area, volume, and area between two curves, because they are all physical things, shouldn't they all be positive? So if you ever come up with a negative, the first thing you should probably look at is saying, oops, got the F and G the wrong way around. And just write a little oops sentence in the right answer. And you got the points and move on. We're kind of reaching the end here. So for the last few minutes, I'm going to talk a little bit more general stuff again. This is the latest version of Canvas. I'll put it on student view properly. Come on. There we go. Maybe make it even a little bit bigger. Right. The things that are not there are going to be your Desmos and your GeoBra and direction field ones. I just haven't got round to moving them up there, right? I'm kind of keeping them here right now because that's probably helpful for your homework and so on. They will be here. Have you noticed that I've now got placeholders? This is just a shell, it doesn't do anything. But on the day of the final, when you click on that, that's where you're going to upload your working for your final exam, right? And is this the right number? Is it 10 till 1? I'll have to look that up. Final exam. When is the final
I think
exam?
it was
Starts at
1 to 4.
1 to 4, that's better. I've gave you the same time as one of my other classes. I will fix that right now. As soon as you leave, I will fix that. Right,
Okay,
so it's 1 till...
It would be kind of hard to upload our test by 1:30 in that.
It would be very hard. You're right. So, well, I'm glad I did this. It is Tuesday. Agree with me, it's at least Tuesday. Okay, I got the day right. So it will be 1 to 4. Now, if I click on this, nothing will happen. No, it's just blank. But what will happen on the day of the final is that when you click on this, the final will appear as a PDF. I'll say it again because some people forget. On the multiple choice, there's only 10 of them, not as many as the practice has. All I want to see is the answer. Number 1 is A, number 2 is B, number 10 is C. Section 2, if I don't see working, you ain't getting anything. So if the right answer is 42 and that's all I see, you're getting 0. Because you could simply just plug it into Mathematic and get the answer, or some other way of cheating, and that's not allowed.
What's that website again?
Not telling you, man. You'd have to learn how to make the software happen, but it's not that hard to learn, so I wouldn't do it. Where else are we going with this? Well, once I finish the upload thing, actually I got the upload right. No, I didn't. These are both wrong. It'll be good to go. Monday, you only turn up if you think it's going to improve your grade, because I only count the top 4 tests. So if you've already got really good ones, you might want to use that time to revise for your final. It might be more useful of your time, right? So if you don't turn up on Monday, you'll still get the attendance for it, right? You're still getting the point for being here, because I'm assuming you're just here in another place. If you do turn up, if it improves your grade, that will fix your grade. You know, I'll kick out the worst one and replace it. If you do worse, it has no effect. I'll just ignore it and you'll keep the 4 that you've got. So it can't hurt you, right, if you do it. But you have to decide, for you, is it worth it? If I got good enough tests, I don't think I'm going to do better, especially when I know what it's about, and then, you know, whatever. That's fine too.
So just a quick question.
Mhm.
So for the final exam, would we just write the letter for our answers for the multiple choice question in our notebook and then just move on?
Adobe picture it and turn it into a PDF like you do with all your work.
Okay, so we just write the letters and all the work down in our notebooks like normal.
Well, you might have scratch paper working, probably will, but I don't want to see it. I just want to see the answers to the multiple choice, right? Now, I'm not saying don't do working. I'm just saying don't show me your working. Right about that. If you take more than 5 minutes in a multiple choice, you're doing it wrong. Pick C, move on. When you're doing section 2, if you get really stuck on a question, don't do it again. Leave it. Do all the other questions first. Once you've finished everything that you can do, go back and have another look at it. And the worst thing you can do is spend 15 minutes on a question. At the end, you know it's rubbish and it's just not right. You know, sometimes you just get a feel for an answer. You know it's not right. And then you do it again for another 15 minutes. Can you use up a half an hour on one question that's not worth it? So if you get stuck on a question, if you know you're going to get stuck, skip it. If you know, I'm horrible at volumes of revolution, I never get those damn things right, then if there is a volume of revolution question, leave it to the last question. Right? That way you can spend as much time as you've got left on it, as many different versions, until you get it right, hopefully. If you do a question, like I mentioned earlier, and it's negative and it should be plus, you can do the little oops sentence. So I'm just repeating myself there. Since you get partial credit,
when are you
if it's
deleting all of the WebAssign and everything?
Yeah, it's going to disappear. It won't disappear until Monday is finished. Right? So all the WebAssign homeworks will disappear. You won't be able to see them. All the Canvas stuff will disappear. All that will be left will be this one page with the test in it, the place where you upload, a table of integrals will be there, the final exam formula sheet will be there, and the software for graphing will be there. Everything else will have disappeared. So you need to write your own notes down. Right? You have to figure out what you need to help you, and you just have them at their side as you do your test. I think I've covered everything. Well, it's kind of bye-bye, and it's kind of sad, as I've been saying in other classes, because I've got used to you, even Evan, and I'll miss you. And drop by and see me. Right? When we're physically here, I have candy, I'll give you some. Or in Evan's case, he will bring some. And just tell me how you're doing. I'm always interested in my students. I like to find out all the cool things that they're now doing. Okay, say hi and bye-bye. I'll hang about for any questions that you might have. And it's been fun.
Thank you.
Thank
See
you.
next time.
Bye-bye,
Bye.
guys.
Thank you.
I just had a follow-up question on the volumes of revolution.
Yes.
So I remember in one of our tests, the question was like the volume of like this just one function rotated about, say, x equals 3. So what if it's not the x-axis or the y-axis, but
then you have to do a different formula when it's not the x-axis, but say parallel to it, right? So I'll show you what that would look like if that happened.
Yeah, I was gonna ask about that too, because I was like looking at my notes and I wasn't sure exactly.
Yeah, I'm sure I got that wrong in the test.
Okay. Let's pick a simple function that I can draw. So let's suppose it's y equals x squared plus 1, right, which is this guy. And we're going to rotate it about the line y equals -2. And so the volume of revolution of this shape would be what you would get. Just drawing my pen over my t-shirt there. It would probably look something like this, where this would be -2. Imagine what the shape might look like, right? So how do you get its volume? It's the integral from A to B, right, from start to finish, right? A to B, pi, and it's the big radius squared subtract the small radius squared. These are just placeholders. So you take your guy here, right? And you basically, oops, I've given you the wrong formula there. I apologize. Since it's only one function, there's only going to be one radius. If it was the area between two functions, you'd do this version, but we're focusing on one. The radius is the distance from the axis of rotation to that point. So just randomly pick a vertical line, and that's the guy I'm calling the radius. And we need to know what that distance is in terms of x. So here goes. Would you agree that the distance from here to here is 2? And then the distance from here to here is essentially what? Whatever f of x is. So this particular one would be the integral from a to b of pi 2 plus f of x squared dx. But f of x will be a function. In this case, I've chosen a very simple function. It's x squared plus 1. So it would be the integral of x squared plus 3 squared, right, when you combine that. Can you see that just ends up being an ugly polynomial, and then you integrate it in the usual way? Now, if it was two functions, can you imagine there was another one up here, and it was this area that you were rotating? Then that's where the big square take away the little squared would come from. And that distance there would be my little one, because it's closest, right? So that would be my little one, right? And can you imagine going from here up to that one would be the big radius? And so what this would look like, it would be 2 plus, I'll call it g of x, 2 plus g of x all squared, take away 2 plus f of x all squared. Okay. And horrible foiling and polynomials, and then you integrate it.